All right, now we see when we use E or Z. Okay, when do we use E or Z? We said for E or Z, we'll be having exactly the first same criteria as cis or trans, which says that the two non-identical groups on each carbon in double bond, there are two non-identical groups. There are two non-identical groups on each carbon in the double bond. Each carbon in the double bond is connected to two non-identical groups, this carbon and this one. This one, is it connected to two non-identical? It's connected to chlorine, yes, and on the other side it's connected to a carbon, sorry, because it's the end of a line, you can see that, so it's a carbon, which they are different, right? And then here on the other side we have Br for bromine, and then the other side we have one carbon at the corner, then two at the end of the line. So this one is connected to two carbons, and on the other side bromine. So yes, it missed the criteria. Well done. Now we say, is there anything else you need for E to Z? No. We can use E or Z in this case. So that means even the one where we use cis or trans, E or Z can work on it. It's applicable, but we don't use it because it also meets cis or trans. So something that meets both E or Z and cis or trans criteria, we use the cis or trans. So we always check cis or trans first. Then if it's not there, we check if there's E or Z, right? And we know what E or Z means. E or Z simply means that atom on the left of the bond and the atom on the right side of the bond, all of them, the one on the left is connected to two different atoms, the one on the right is also connected to two different stuff. So there we go. Now, what do? We need to see if we're going to, we've seen that E or Z works. Now we need to see who is going to be E, who's going to be Z. Is it going to be E or Z? We put our dotted line through the bond. Remember that in some examples, you see them going across like this. We don't go across, we are going through. That's the method we are using. What are we going to do then? Well, we check. Look at what this statement says. For priority, you use molecular weight. So we are going to see who has higher priority on the left and who has higher priority on the right. And then we join them and see if they're on the same side or different sides. How do we see who has higher priority? We look at the molecular weight. What do we use to find the molecular weight? We use the periodic table. So let me load the periodic table. Okay, and on this periodic table which you've put here, we can compare chlorine and bromine. So you can be checking with the periodic table you have. So we check chlorine and carbon, which is on the left of your double bond, right? On the left of your double bond, on the left side of your double bond, which is they're connected to the carbon on the left. Let's see, chlorine versus carbon. Carbon here is 12, chlorine is 35. Okay, we look at the mass. So chlorine has a bigger mass. So that means he is the one who gets priority here. And then we go compare. In here we have a carbon on the corner and another carbon here. So we are going to, we can already see that it's connected to this carbon. That's the one we care about. The one it's connected to. A carbon, yes. So we are comparing a carbon to what? We're comparing it to bromine. Okay, let's compare. Let's compare the other. Compare. Carbon is again 12 and bromine is 79. So bromine is higher priority. So because he has a higher weight. So what do we do now? We connect the guys with higher priority. Let's connect. We come like this, go flat, and like this. Did we cross the dotted line? Yes, we did. Oh my gosh. So what it means is that this is going to be an E. We are using E or Z this time. So here is going to be an E. Because if you see, E is the equivalent of trans. In other words, it behaves like trans. Then for Z, Z is the equivalent of cis, which here's what we joked saying. Z is the same side. Okay? Z means they are on the same side. Okay? They are on the same side. Don't forget that. You would say, oh, Z means that they're on different sides because look at the letter Z. No, not in this case. When you see Z, it means they're on the same side. So here they are on different sides of your dotted line, which means we are going to use E. E is for different sides. Don't forget that. Never, ever, ever. Okay, let's do one more example or two more examples, and let's see where we can use it again. Well, we're going to put it, let's do this one, which says I'm going to put something like this, goes in, and then let it go like this. And then, wait, let me make it go like this. Okay. And on this side, we put our double bond here, which we would make it be single here, I guess. And then here, make it connect to chlorine. Okay. Here, we'll make it connect to chlorine. And then here, we could have it like this. So what is this? Okay. Make it connect to chlorine like that. Here's our double bond. Here it is connected like this. Great. So let's go with this one. What is this going to be? We check. Carbon on the left, is it connected to two different things? Yes, here it's connected to like 3 carbons. Here it's connected to 1. Okay. What about on the right? Here it's connected to 1. Here it is connected to, it's connected to a carbon. Here it's connected to a chlorine. So nice. So that means the one on the left is connected to different things, and the one on the right, different things again. But now, the moment you see it having a carbon on the left and the carbon on the right, that means we are going to use cis or trans. Okay, we are going to use cis or trans. Although Z works, okay, we're going to use cis or trans. So what is it going to be? We come from C to the other C. We see they're on the same side if we put a dotted line through our double bond. So that means this is going to be Cs, okay? We don't use E or Z, right? Now let's do one more. What about if we have it like this? Here is my double bond. And here I'm going to make it connect to one other carbon, okay? And then here I'm going to make it, let me close this. Connect to 1. Here I make it connect to 2. Okay, 1 like this. Then the other one like that. Then here, let me make it connect to 3, if I can. 1, 2, 3. Then here I make it connect to 2. Or let me make it connect to a Cl. I could have made it connect to even 5, you know? If I wanted, like to put 1, 2, 3. Okay, it's now connected to 3 over here. And yes, this one, I'll make it connect to 2 maybe, so that they become different. Right here, I'll make it connect like this. All right, so what 2 other? Let's see. Let's check with this carbon. This carbon versus this one. Right, what do you have on the left here? 1, 2, let's see, sorry. We have 1, 2, 3 carbons, right? 1 is here, 2 is at this, and third one there, right? This one is connected to 1, then 2, 3, 4, isn't it? It's connected to what? It's connected to 1 here, which is connected to other ones here. Then here it's connected to 1 carbon here. Here it's connected to a chain of 2 carbons that are together. So basically, anyway, we see that they're different. Whatever is happening. So if we look here, what do I have? Here I have a carbon. That's something I want you to learn here with this example. Here I have a carbon, basically. Here, what is this carbon in my double bond? What is it connected to here? It is connected to a carbon. What about here? It's connected to a carbon again because it's the end of a line. Then what about here? It's connected to a corner, which is a carbon. So basically, it's just connected to carbons. Now you say, what do you do in that case? You want higher priority, okay? Now here's how you get higher priority. Here's the tip. When things are connected to the same guy, let's say carbons, they're all connected to carbons, right? But the carbons are different chains, are in different chains, so they're different. What would I do? I have to use E or Z here because they are not, there is no similarity. So what I do, if it's connected to carbons, you just choose the one with more carbons, the one that is connected to more carbons, okay? So if I see here, this guy is connected to this carbon, which let me put in a different crayon so that you see where I'm looking at. Look here where I'm putting in blue. This carbon is connected to 1, 2, 3, 4 other carbons. Okay? Versus this one, which is connected to 1, 2, 3 other carbons. So the one which is connected to 4 has higher priority. So I'm going to be using this one. Then on the other side, this carbon is connected to just hydrogens. Then this one in the corner here is connected to another carbon. So it has more. So I'm going to use this guy. Then I put my dotted line ding, 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 through my double bond. I see if I come from here, go like this, and go down here. Have I crossed the dotted line? No. We are on the same side. Here you do it this with a pencil. You're on the same side? Yes. So what is it going to be? It is going to be Z for the same side. So in here, I'm going to use Z for the same side. And that is how you do for E or Z. Okay? Should I do one more without making it scruffy since you guys now know? Let me do one where it's easier to see. I'll do it like this. C double bond, no more using bond line. I'll actually use more structural formula. So now what is it going to be? Here, let's make it connect to a C2H5. Then here, it is connected to a CH3. Then here, it is connected to a Br. Then here, it is connected to a Cl. Now, what are we going to do? We see this carbon in the left side. Is it connected to different things? Yes, one is a Br, the other one is a Cl. All right. What about here? The other one is a C2H5, the other one is a CH3. They are different. Great. So because it's connected to different things, now let's see. All four of them are different, isn't it? Yes. So we're going to have to use E or Z, right? Exactly. So now what are we going to do? Let's choose priority on the left side. Let's choose priority on the left side. Who's heavier, bromine or chlorine? We go to the periodic table, which I'm showing you right now. And in the periodic table, you can see that bromine is heavier. It is 79 whilst chlorine is 35. So we are going to use bromine, which is going to be Br. Now, what about C2H5 and CH3? Who are we going to use? Well, remember we used the carbon which is bonded to more carbon. So this is bonded to one more other carbon. So we use it in this. And now if we put our dotted line like this, you can see that if I follow from my highest priority to the other one, it is going to be on the same side. So I'm going to use Z. And I'm done with this.